Okay, let's go live and tell some people that we are live. Join me for Advent of Code 2021, day 15. Okay, let's also send this out to Telegram. And let's share this on a select Discord. Okay. That should be it. Okay. Let's see, day 15. I had such a great time yesterday with solving day 14. I was so happy that I figured that one out, man. So let's see what day 15 brings us. Let's see, day 15, Sheeton. Okay. You've almost reached the exit of the cave, but the walls are getting closer together. Your submarine can barely still fit, though the main problem is that the walls of the caves are covered in Sheetons, and it would be best not to bump any of them. So do we want to know what these are? Okay. Mollusks. Okay, so it's a sort of, okay, know that from before. Restricting your motion to 2 dimensions. The shape of the cave resembles a square. A quick scan of Sheeton density produces a map of risk level throughout the cave, your puzzle input. For example, you start in the top left position, your destination is the bottom right position, and you cannot move diagonally, so only left or right, okay? Left, right, up, down. The number at each position is the risk level. To determine the total risk of the entire path, add up the risk levels of each position you enter. That is, don't count the risk level of your starting position unless you enter it. Leaving it adds no risk to your total. Okay, I need to read that again because it didn't register. Your goal is to find a path with the lowest total risk. In this example, a path with the lowest total risk is highlighted here. So 1, 1, 2, 1, 6, 5. Okay. The total risk of this path is 40. Okay. Let's see, I keep triggering stuff here. So 1, 1, 2, 2, 2, 1. Now 1, 5. 1, 1, 3, 2, 3, 2, 1, 1. Okay. For now, let's see if I do this here. Console. Okay, so this is 41, so that means like the starting point. Okay. Each position that you enter, leaving doesn't count. Okay, so you start at this one, but you don't count this one, so each one you move into is added. Okay, so that's fine. So this is just a pathfinding algorithm. Keep track of the score, the best score wins. So what you do is you try every path, you branch out at every option. And once you reach a score that becomes the best score, once you equal that score, you stop processing because you haven't beaten it. So, okay, I think we can do that. Day 15. A lot of these problems are solved with like backtracking and recursion. And I'm curious to see what part 2 is, if there's a bigger challenge. So far this seems pretty straightforward, but usually when I say that, those are famous last words, and I struggle later on. So yeah, let's do it like this. So I assume this is bigger. Yeah, okay, fine. We'll start with the puzzle input anyways. See that select. I can basically say as int 32s, right? So now this is a list of int. I should probably make like a helper function that just turns it into a grid, because this occurs so many times. Okay, so x and y start was lines of count minus 1 lines 0 count minus 1. Okay, so we start an end position here, and we probably do like void. It's probably not a void, but for now I write it as a void. Find path. Dun, 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 dun. We have a list int as the map. Boom, 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 boom. We should probably keep a list of places we've been, because we don't want to double back. That would be stupid. Hash set int x int y. Just visit it. Int risk score int x int y bum, 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 bum. Target int best score, something like that. So then we would do a find path map. I call it lines, but I should probably call it map here. Map. New hash set, and there's probably one in there like start pos. Start pos. Score is 0, target is end pos, best score is 0, and I should do this int.max value because we haven't found our target yet. So we have a list int x int y moves is new this. We do 0, minus 1 is up, 1, 0 is right, down and left. So these are the valid moves. Current post is visitor.last. Not sure if that actually works. Let's see. We do current post target this is our current score and our best score. Okay. So we don't need to do that. So we now do for each var move in moves. Target. Okay. Okay. We call this end target, and we do target is current pos dot x plus move dot x current dot y plus move dot y. If not visited contains target, and we also need to make sure that it's a valid move. So we need to make sure target dot x larger equals 0. Larger equals 0 and target dot y larger equal to 0 and target dot x smaller max x and target dot target dot y smaller equal to max y, and now we do that. Okay, so if all of that, we need to define these two. So we go int max x is, we have those here. Actually, that is funny. Int max x is npos dot x, max y is npos dot y, because it's a bottom right corner. So we have those values as well. This is becoming a long list of parameters, but parameters. That makes life easier. Let's see, is this still correct in the order that I passed it here? I don't think so. Current pos becomes start pos, end target, risk score is 0, best score is max value, max x, max y. So these are all the arguments that I need to pass. And if this is not something that we visited before and that we can do, we should execute this find path. And let me see what the result should be. This will probably be some of the stuff that we pass in. So that will be path, risk score. Right. Cool. Success. That, like that. Okay. So here we do var result is find path, and we do the same, but we pass in path. That's the same for everybody. In this case, it's called map. Wait, that's funny. Here it's called map, and when I do this, it's called path. Sorry, that's the return type. I'm blind. Okay, let me see. So we pass in path. We do visited, and for that we create a new clone. So we do far new visited is new hashed. We can actually do this. New blah. And I can put in a list, I think. Right, visited.toArray. So this will create a clone of those. New visited. Current pause will be target. And we also need to new visited.add target. And target is still the same. Risk score will be risk score plus map target dot y target dot x. Oh, let me just do it like this. Dun, 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 dun. Best score still valid. Max x, max y. So now we do if result. Success. And result dot risk score is lower than best score. We do best score equals result risk score. Should probably also save the best mapping in here. Let me see if I do it like this. I can probably keep the bar. Local result. False. What isn't it like this? Does not exist. Ah, I had a typo in here. Risk score, okay. So let's see, if result, and this becomes local result. Best score becomes that, and we can just say result is local result. Return results. So in this case we return the best path. Let me see. Yeah, I think this will be it. Something tells me I'm forgetting something, but I'm not really sure, but we'll find out soon enough. So yeah, this will branch out and find more, and it will go on until it reaches the end, and that is good. In this case, let me see, if target is this, we also need to check if target is end target, and else we do this. And this means result. We can actually return here, I think. Yeah, if we find the result, then it's good. So we return true. Target. And return a risk score plus, and then we get the local risk score here. Let me see. Okay. Let me see. So once we reach a target, that is that. And we only care about reaching the end result if the score is better. Let's see what happens if we run this. Console.writeLine. Success, the result at success, score, result at risk score. Let's just go into day 15 now and see what happens if we run this. Oh, pause break, that's the wrong one. If it ever finishes. Doesn't look like it. Oh yeah, I forgot the early exit, right? So what we need to do is int new risk score is this if new risk score larger or equal to best score. Continue. Otherwise we can do this. So this should let us exit early out of all the suboptimal paths. The problem is, yeah, let's just see if it runs. Okay, 75. That's not correct. So let me see. Best score is that, okay. Let's see, call stack. The thing is, this needs to be global for all the paths. I wonder if I need to ref this, but the fact that it didn't get a better score anywhere is weird. So let me see. Visited 16. So it took the right path here to the right, and then it went down. I wonder if my mistake is stopping when you hit the target. because what is the local score? The risk score here is 73 already. Okay, so, the curious thing is it's already on move 2 in this iteration. So what we should probably do is actually follow the one path that we know it has to take and see why it stops somewhere. Dun, dun. Because yeah, this is very hard to debug. Right, so this one, let's see, because we are currently at 9.7. Okay, so this one should now backtrack a lot. Yeah. So what we need to do is make sure that this will become a reference for the best score. Because I think it's lost somewhere. Let me see. I can do console right line new best score. Best score. Let me see if I do this, how many times will I print it out? I think a lot. It has a new best score of 0. That is incorrect, and never does it have the one that is supposed to be 40. So that's interesting. So let's see. We do int best score. And I've written this before, and I don't think it needs to be by ref there, but is int max value. So I'm really curious to see how the 38 one came to be, but at least that solved the issue there, except that it didn't return the final best one. Ba-dum-bum-bum. Let me think, because I just wrote something like this before, and I wonder what I did different there. No, this also just returned the best result. Yeah. Let me just look at it again to make sure that I'm not doing something stupid here. Fight path, local results. Because this one will come down to like the best version. But because this one is updated before it gets here. Haha. Yeah, that's funny. Because now, because it's shared, it will have updated when it gets here, so this one would never get set here. Actually, I can just do and new score is this new score. Am I correct? Let me see. I'm just wondering there. Okay, let's just leave it as is, and I just want to and just do this string dot join and then we do visited. This one is not in sequence, right? Let's see, x dot x dot y. Where's the error? Okay. That's weird because these ones don't even end up at the end place. What am I doing wrong here? Let me see. End target should never change, right? Or should I make a new clone here always? Let me just do that. Let's see if that changes anything. Nope, still wrong. So in this case, target is 9.9 and that is fine. This is weird. Let me see. Local results. Let's find path with local result of success. How can that one return success when it's not? This is weird. This is something I don't understand. Let me see. So now it's success, right? But it ends with 9.9. Okay, so how can this now also be a success? It also ends at 9.9. I'm missing something here, and that's always a bit difficult with recursion issues like this. So let me just see. This should probably only return true when the new score is actually lower. So let's just make sure that we set that here. We do int new score is this. If new score lower than this score. Okay. And otherwise we don't want to new score, and we set best score is new score. Right? So if we do it like this, this should only hit once, and after that it should always be for full pass. So I don't understand why it didn't hit that. Ah, not best score, best score. Right. Okay, so now the best score, we don't have to do that here because we already did that. We keep track of this one. Yeah, I think the thing is actually what I did before was that I kept a list of just all the results and not stop executing, right? If this is a win, we just move on to the next one, and then we do has win, best, right? Okay, maybe that's the approach that I need to take, right? Let me look at it again. Has win. Okay, so once we are better, then we keep track of that value. That's exactly what we do right now. Dun, 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 dun. Okay, so there's nothing different there. But what we shouldn't do is return here. Let's see. In this case, we say result is true, new visited, new score. And we only return there, and this will allow us let's see if this is the the thing that I need to do. Okay, wow. So yeah, that's correct. It still is wrong with writing it. So the problem that we had was that we exited too early. I still write new best score too often because I actually wonder if I even need to do this part because that is wrong. Because that should be here and this should be new visited. I think if I do it like this, it should be correct. Right, okay, cool. Okay. Now we need to make sure that this should actually end up here. So what's really strange is that it still doesn't return in the end the proper path all the way up. Let me see, I should probably do if result of success. I actually wonder why it keeps triggering the local result there. Because this early abort, that's correct, right? You don't need to go down that path. I just wonder why this triggers so many times. So I should probably also make sure that I and local result dot no, I'm a bit stumped by why this isn't correct. Let me just check. So in this case result is success, so it's 75. Now it's again 75. Okay. Ah, okay. It was correct. Okay, my bad. Let's just run it on the input now. I had enough debugging. Jesus. Should probably not write out all the improvements here. New best score. Okay, so that leaves a lot of optimization out of there. Okay. So let's see. How deep is our stack? Pretty deep. So let's see. We have a best score of... That isn't great. Let's see. So this one is 100 by 100, right? Okay. I'm just thinking, is there a way to give a sane max value to the to this, because I think like 2000 should be a sane max value at start, because you take x times y times max value, that should be your max. So let's just do max x times max y times 9. Right, this should be the max value. I hope this helps prune some of the paths already. No, it's still... Because there are so many variation paths that it can take. I have to be smarter about this. What if I say that I do it assuming half value? Oh, 100 times 100, is it that? Okay, so that doesn't really... no, I'm actually... I need to do plus and then times. So my reasoning is this should abort a lot sooner. Just hope the actual value is possible there. So what I did now is saying that the path on average should probably not exceed a value of 5. And I took like straight down and to the right as a reference. So there will be more paths in between. Maybe that's not a good idea either. So this is 10 by 10. Times 5 will be 50 and the path here is 40, but it doesn't mean that that's the best path. And I wonder if I should, because this one just goes down and right, if I should support going to the left as well, left and up. That could be something that I can try. So this is up, this is left. If I just support these, that's actually just... Best score is 935 so far. But I assume those are still too many options or something. Let's just try. Not the right answer, too high, okay. I was afraid of that. 933. This is going... I wonder if there's like... if there is some analysis that you can do to like try and pick a better path, not just blindly try everything. Should probably multi-thread this or something. So this is a bit of a surprise for me, because even limiting it to just bottom and right movement, and I need to shut up Telegram for a bit because it makes too much noise. Just limiting its movements there still doesn't help that much. So yeah, there are a lot of options here, but damn. So we're down to 916, and while I could let this run, this doesn't guarantee that I'll get the answer, because there might be a path going left and down, and I actually think that they might add something like that just to let's see. What I could do is have a bias in there that gives that prefers the lowest route, right? So for each option, it will weigh all its options and then it will take the lowest one first. That might help. That could be cool. So yeah, it's 916 here. I'm going to see if I can submit that and see if I can get lucky, and otherwise let's go to the code and let's look at our options. Let's see. Var options is moves.select x. We do target is target.x plus x.x, target.y plus x.y. Val is map. List int x, int y, int val. Risk, let's call it just risk. Options is new blah, and we do for each move in moves. Int x is target.x plus move.x, int y is target plus move.y, risk is map y x. Options.add x y. What's wrong here? This needs to be current pause. Okay, sure. So now we do for each var move in options.order by x. So risk, right? Let's see. So now we have them sorted by the least risk. Does that make... I need to have this part here. If x okay. That's out of range. Okay, how can it be out of range if we have all the options validated? Can actually just, oh man, all these buttons. Let's see, target can be removed because target is just move.x and move.y. Okay, let's do it like this. Okay. We already know this because we calculate this. It's move.risk. Feels redundant here because we already have it. We do it twice. So since we always need to calculate it here, we can just do this. And this becomes move.target. Okay, we refactored that. Hey, this is a lot better. So now we tried the lower path first. So now we have 668 that we can try. Still too high. Come on, baby, find me a better path. 666. Great. I wonder how long this will take. But in theory, this should cancel out a lot of stuff already. So, and we could actually do even more because once you know the best route, so once you've been to the end once, you can calculate the shortest path to the end and what that would be, and if you're like already too close to getting the score. So like if this is the best score and your shortest path still 10 blocks away, but you're already at 650, then you can stop processing as well. At 660, because you can never get there in time. So there are ways to exit even earlier, but it helps having a really low score as your target. And actually this is still with just the bottom and right movement, so this still doesn't guarantee that we find the correct answer. Okay, so is there something else that we can still do? So we brought it down and we found a result fairly okay. So we tried to prioritize the best moves. Is there something else we can do for this? We can try this one. I think this is really close. I think this is like off by 1 or something. So I can probably try 665 or 664. Because I think the answer, the hint that we got changed. I wish I knew a way to even improve this more. Anybody in chat maybe have an idea? This will run for a while. I wonder what will happen if I just set a low max of like 500 or something. Because that's the issue, right? It goes off on all sorts of tangents that never end up in the in the right spot. But that's not completely true, because I program it to only go either down or to the right. So we don't even run the full moves yet, which is annoying. Okay, so this won't find the answer. Let's try actually giving it more room and potentially find better paths earlier. Or not. Oh wow. Where is it? So right now, best score is 1720. Okay. 1782. Okay, so let me see. I wonder if I limit it here, but no, we already were there. If I set it to 600 or even 500, will that make sure it aborts paths faster? Just trying to see if there's a way to limit going off on tangents that will never yield anything good. I'm just trying to think what are ways that we can limit this, because you could try to calculate the running average, but it varies constantly, so you can't say much about that. I was like, okay, maybe you can make sure that it doesn't try any 9s or 8s, but maybe the best path actually has a 9 or an 8 in it. This is so tricky. I'm really curious to see what the best way is to actually do this. The funny thing is, now that I limit that whole best score thing, I don't even get to any scores anymore. Which is interesting, because when I had no limit, it found a path with 1,000 something. And actually, as soon as it finds a best path, so we were up to 666 before, as soon as it finds that, anything it processes after will abort when it reaches that. So I don't think it's needed to set the low threshold. The only thing I could do now to get back to the point that we were would be to set the limit of something that we know is within it, and that is 667. So this should get us there somewhat the fastest way. But since I enabled all the moves again, even up and left, it might take a while before we get there. Because every step to get there will be exponentially bigger. actually just allowing down and right makes sure that the path is the shortest, right? That the path that the absolute path that you take is shortest. But I wonder if they actually made it so that it has to backtrack something to get a better path around something. Or that the shortest path is always the fastest. In this case it doesn't get anything, so... So if I run it like this, I should get our answer fairly fast, but... It still took a while to get there the first time, but... There it is, okay. What can I do, what can I do? I wonder if it would be smart to like plot a block first. To like analyze a smaller square first. That could be... That is interesting. So... Yeah. What if we would cut up the entire search space into smaller pieces and just try that first? So instead of taking every part, just analyze a smaller part first and just do it blockwise. I wonder, how would I code that though? I think that might actually be the way to go here. To just not look at the entire thing, but just look at blocks of 10 by 10 and see where to go from there. And you could actually have some overlap there. I wonder if you like take just a little bit bigger picture of what you're searching for, find your path there, and then maybe expose half of it to see if it's still the best. The thing is, if you look at smaller sections, this isn't the final goal, right? I'm just wondering, when can you determine that a path is good? Because my idea was like, if this is the whole search space, now we can do basically anything from like this to this and everything in between, right? So what if we divide this into a grid? and then just try to analyze grid by grid. The thing is, if we always set this point as the absolute as the end result, we don't get what we want, because we want to go here. So I think you have this is like a pathfinding algorithm. I don't really do much of those, but I think there has to be like maybe a weight. So the further down and right that you go, the closer you are to this one, the higher priority it is, but still have the numeric values way in there. I wouldn't know how to code that though. It's an interesting problem. Probably something somebody else can solve fairly quickly, but because the issue that we have right now is that it's just going all over the place, right? And it finds one score, which is it's okay. We found an okay score, but now it's just trying to backtrack all the other possible routes to see if there is a better way to go about it. And that's just really tough because there's so many options. So my idea was to just if you plot a path like this and this is the end result, and then maybe next time start halfway here where you end up and then shift the target over and just keep plotting like this to see if we can get there. I didn't draw it in a perfect script, but yeah, I'm just trying to see if there's a way I can do this. Because basically what I did with eliminating the up and left moves is just it's not correct because they should be valid moves, but it's also I could probably also weigh those in here as well to prioritize those that go towards the target, right? The left and bottom, and I could actually based on like the pure distance between the 2 points, give the most weight to the one that favors going in the right direction. Because I think that's the biggest issue here, just making sure that it's weighted in the correct way so that you bring down the best score as much as possible, which then reduces a lot of paths. I just don't know if I know how to do that. So I wonder where it is now with, like, in the grand scheme of things. Current pass, it's still near the bottom right? Yeah. So it's now looking here to see if it can find a better path. And it has a risk score of 651, but it still needs to be. That's one of the things that I said before, like, okay. Let's see. Oh. So current pos dot x and target dot x minus and target y minus current pos dot y. So it still needs to go 16 positions, at least, right? So these are 16 moves. It has a risk score of 651, plus this is bigger than the best score, so it should already stop. And that's actually something I can do here as well. I should add this actually here. So if that's a long list of conditions by now. So I have the X check, the Y check, and this. There's something more that we can check, and that is if it's actually still valid to go there, and that would be n target dot x minus x plus n target dot y minus y plus risk score plus okay, let's see, this already needs to be smaller than best score. And actually need to add the risk there as well. So let's just do that here as well. So if it can't beat this, we have no reason to go there, right? So let's see. All right. Okay, let's do that here then. If now we add the option. Does this help? Not a lot. It should help a bit more with exiting early. But yeah, there's still so much ways it can go. And this is still with just going to the bottom and to the right. So in theory, I think we should do this as well. I wonder how long it takes to get to the 666 score now, because I included the up and left moves as well now. So that means they can go crazy a bit. A long time, as you can see. So this is all still within the within these 600. It still can't get there. So I think I need to call it here. And I should probably do some Googling and see how I can do the path finding for this one better. Because I've done a few optimizations, right? I've done the score. It does the best score it can find first. So if it walks here, it sees a 1 and a 1, it will try those two first. And then from here it will try the 3 part first, and then here it will try the 1 first, and then it will try the 3 first, and then the 6, and then it will go up to the 1. But that's because I allow it to do that, and I'm still not sure if I need to allow that. I mean, I know this isn't the answer. Which sucks, because I really want to do this, but I think I need to go find some more info to see how this works. Let me see if I can path finding. I'm not sure what A star to be. I actually prefer, let's see, pathfinder with weight routes. Work in the park. It costs the least. I don't really care if the shortest possible route. So far it seems A star is out of the question, and I honestly don't understand Prim's algorithm. Let me escape, okay? Let's see, do I vision map or graph nodes, eat nodes, and each egg node? If you allow diagonal movement, only on the 4 neighbor nodes are valid. There is no edge between any. Okay. This is enough to implement a simple depth first search. Ah yeah, okay. In which you keep a queue of unvisited nodes. The shortest path between your source and destination, as long as all graph has a negative. Naive Dijkstra. Okay. Please note that it's impossible for the lowest code route to contain a loop. Okay. If I look at if you look at this GIF, right, this is basically what I'm writing, but it's just too slow to find all of them, I think. Well, that's not true. This one, my version tries to go as deep as possible first and then go out. Maybe that's the issue. Yeah. I'm not gonna go do this now. I think I'll go back to this later. It's already late and I need some rest, so I'll sleep on it and see if I can do this tomorrow. Man, that really sucks. I wish I could do this now, but yeah, I don't have the energy to tackle this right now. So I'm sorry for an incomplete today. I hope you still enjoyed me struggling a bit, and maybe see you tomorrow. Bye bye.